Right, let's see how we can use the triple beam balance. And this is showing some steps. Right, if you cannot remember, just focus on this. Okay, here you can see the triple beam balance, and first of all, you have to move, you have to keep your weight, and you have to note that this is in the 0th position. So that is compulsory thing. After that, you are keeping the mass there. Okay, note that there are 3 levels. Okay, this is the largest. When you keep the mass, you can see it goes up. Then you have to move the largest one. Let's move 100, move it to 100. It's not going down. Let's move into 200. It's going down. So 200 is too much. So you move it back to the 100. Now the second option, let's move it to 10, no, 20, no, 30. It goes down. Let's move back to the 20. Okay. Then the smallest one, you have to slowly move that one by one. Okay. At one point, it will start moving down. And at that point, you have to start balancing it. Once it perfectly balanced, once it's in the 0th position, or when it, like point to the 0, then take this, measure this as 125, here 125.8. So I think that is the measurement there. So you have to take the total 125.8. So that will be the total. It seems, yes, 100 there, 20 there. Here you can see it's 5.9, right? 125.9. So that is the total. Right. So that is, this is in the grams. This is in grams. So why we are using triple beam balance here? The reason that you are using triple beam balance is to find the density of unit of water. So let's take 1 liter or some amount, and then you can fill the density bottle, right? Or you can say this is like a gravity bottle. So you can fill it with water, and then you have to measure the weight. Then you can refill this same amount. You can refill using distilled water, boiled and weight. And also you can compare the masses in so different environment. Right, distilled, and you can make like heavy water as well as, then you can measure the tank water and brackish water, fresh water, marine water, right? Mudu jalaya, so fresh water, miridiya jalaya. But so you can see these will give different weight. Actually, you can use this feature to identify the identify unpolluted water, or you can identify pure water from that. Because so whatever the mass in the pure water, you won't get the same bottle with other water samples like brackish water or fresh water, even tank water. You might get different values, but not like the distilled water. Therefore, that can be used to identify the purity. That can be used to identify the purity of water. That is this practical. Get water from different sources, measure the mass, see the difference, and identify the purity, which is pure water and which is not. So that can be distinguished. You can see pure water. It is 1,000 kilograms per, right? So you can see if you take 1 cube meter, right? So it is 1,000 kg. Ghana meter agattama, right? Eke bara wenne කොච්චරද kilogram ඝන මීටරය කියන්නේ මීටරේ කොටස. You take that, the weight is 1000. So these are densities given for the different. So aluminium, it is heavier than water. Iron, more heavier. Copper, lead, gold, you can see this really heavy. So these densities are used to identify. These densities are used to identify the purity of the particular substance. These are given for the pure substances. If this is different from the given values, then you can identify that as non-pure substance. And again, the purity can be identified using melting point and boiling point. So as you said, melting point of water is, sorry, melting point of ice is 0 degrees. Actually, how can we measure that? First of all, we have to use stirrer, right? Stirrer or steering tube. Then a thermometer. So you have to create something like this. And then you can like use ice chips and boil it. But you have to keep this in water. Then start boiling. Then gradually the temperature will move up. Normally, when you provide heat, gradually the temperature will move up. Sometimes it can be minus degrees. From the minus degrees, it is moving up and it will stop in one level. The time and temperature, you have to measure that. The time taken, so different times, different temperatures. When you start, let's say when you start 9-7, the temperature was minus 4 degrees. 9-10 with the temperature is, let's say, minus 2 degrees. So then 9-15, 0 degrees. Then 9-20, 0 degrees. 9-25, 0 degrees. Likewise, in some point, it will stop changing. It will increase change in the temperature. Temperature. You cannot say it's not changing. It will change. The bindu change. But after changing it to 0, after 0, it's not changing again. It will start changing again after full conversion only. ඊට පස්සේ තමා ඔන්න 1 2 3 විදිහට temperature වැඩි වෙන්නේ. ඒ වෙනකන් වැඩි වෙන්නේ නැහැ. So that point we call that melting point. Actually, for pure water or pure ice, the melting point is 0 degrees. What will happen if salt or something mixed with this? Will it be the same or will it be different? What do you think? So if you mix salt with water, will it be the same or will it be different? Sanidhi, can you hear me?
Yes, sir.
So if you mix salt with ice, or saline ice, or salty ice, will it be same or will it be different?
Different?
It's different, right? Salt water or salty ice or the saline ice, it is not the same amount. It can be high or it can be low. Actually, you can do the practical. So same practical by putting salty ice. So then try to find the boiling point of that. Sorry, melting point of that. The boiling point, again the same. You can see here ice, melting point is 0. Sulfur, it is high degree. Lead, aluminium, copper, iron. That is why we use aluminium material or iron for these cookers. The reason is their melting point is so high. So we can boil water in aluminium container. We can boil water in copper container. We can boil water in iron container. Or we can even boil water in lead container. But sulfur container is not so good, because if you increase the temperature a little, sulfur will also melt. Therefore, To boil water, we can use one of these. Actually, have you seen this kind of video circulating in internet? So this is actually again a like a survival tip. Boiling water in paper. Right? So you can boil water in paper cup. How can that happen? Right? How that happens? Yes. So let's use. Okay, even this can be done. But let me show. Okay, let's see the paper cup example. You can do this with the paper also. Just wait.
Today, I'm going to do an experiment. It holds the cup off the floor and supports it, makes the stand bend the framework a bit, and try to hold the cup level. Can't really see the flame very well, but it is lit. And I'll show within a couple of seconds, the blowtorch sets it on fire.
This is a normal cup without water, you can see.
And it only takes a few seconds before it completely burns up.
It burns up, right?
But now let's see what happens to the cup full of water. When I hold the flame against the side, you can see the paper starts to turn black, but doesn't burst into flames. As I move the blowtorch around the cup, it blackens the paper wherever I point the flame. I worked my way around the entire cup, and it didn't take long before small bubbles started to appear on the side walls inside the cup. I could see some steam starting to develop. The water was getting hot, and the cup wasn't on fire. You can see the water started to change colour and took on this burnt yellowy brown colour, which transferred from the blackening of the paper cup. I kept moving the flame round and around, and the water looked like it was getting really hot. After a few minutes, I did notice it had sprung a small leak. So I took another paper cup and poured the hot water into that. I wanted to know how hot it had become, so I used a thermometer and found we'd only managed to achieve about 63 degrees C.
Okay, so with this practical, you need to get an idea. So the paper won't burn. If there's water, paper won't burn. And so you can do the same with the balloon. Balloon and water. Balloon and water. You can do the same practical. Typically, a balloon will blast when you point that to, when you point that to, or when you keep it underneath of a candle light, it will blast.
It's exactly the balloon, blow up the balloon.
Right, this is a.
So here, okay, so now
Without taking much time, let's move it.
I want you to take the balloon and I want you to hold it over the top and just slowly get down to it. How close do you think you can get before it'll pop?
You can see what will happen. So when it is closer,
Finally, you get nice, right?
it will
Just a little
blast.
explosion right there, not so bad. And we get
Oh.
yeah, not bad. All right, so
Studio crew running for their lives. This is a good one.
now this makes it even more fun. So watch what you're going to do here. You remember you have to have your safety glasses.
Got
for
'em
this.
on?
Have fun.
Well, I have a long
So
history
now
with
this is
these.
going to be a problem. Okay, so watch. Take the balloon now and blow it up. You learn the difference between blow and suck.
Clearly.
Okay, so this is very, very cool. So this one will be yours. Oh,
Okay,
if
so
there wasn't a hole,
in
all
there.
right.
Oh,
This one will be perfect right here. Okay, see it inside. Okay, so now watch what
must have
happens.
been from another experiment.
Please. All right. So now this is very cool. Watch what happens. The camera's going to get in real close. Watch this. We're going to get down lower and lower and lower. And look at this.
You are kidding me.
No,
It
it'll
doesn't
just sit there.
explode?
It just sits there.
Well,
Now,
I don't
water-
understand that science.
Isn't that very, very cool?
These are latex,
Yeah.
aren't they?
Water is a great conductor of heat. So it really does a great job of pulling it all away. Isn't that fun? So it pulls all the heat away. And so now that heat goes through this very, very thin little membrane that's here and starts to heat up the water. And as the
I
water
would
starts to
never
heat
have
up, isn't
guessed that.
cool?
Not in a
So it just
million
kind of
years.
keeps on going.
Will it
keeps on
boil?
going. Well, if you got it long enough there, and so who has time
I'll
to
be
do that?
darned,
Try it.
yeah.
Just make sure that I'm not lying to you.
I
right?
would
If I'm
just.
lying, I'm dying,
I would be
right?
sure that
That's
that
true,
would
so you're
just
just nice and
explode.
close.
So
Yeah.
it's the water that transfers the heat.
Yeah, and so it's just a great conductor.
Will you
And so
look
it
at
pulls
that?
away. Now,
Now you can see this video and witness with this what will happen. So you can do this experiment as well. This is another interesting science experiment. So that will show that the balloon won't blast. The reason is, so when water is there, it is working as a conductor too, right? It is working as a, like it is absorbing this temperature and it will stop burning that balloon or the paper, right? With the experiment, you can understand until it reaches the boiling point, it protects the survival, it protects the surrounding things also. But when it is fully evaporated, when it is fully in the gaseous state, or when it passed the boiling point, right, then that protection will not be there. When it passed the boiling point, that won't be there, right? So this is just, these practicals are some examples for this melting and boiling point experiments, as well as how the thermal conductivity can be tested. So you can use these experiments in that. Okay, today we have discussed the melting point, boiling point, as well as the density and how we can measure that. So these are some other boiling points. You can see ethyl alcohol. Alcohol has less boiling point. It will become gas soon than water. But sulfur, lead, and iron to become gas, it needs very, very, very high temperature. So basically, that is why in the sun, in some planets, right? So if you study, are you interested in astronomy? Following astronomy or not? Yes.
Yes, sir.
Are you following that? Yeah. Then you can see some planets, they're having different gases in their like in the atmosphere. In the air layer, there are some gases. Based on the planet temperature, so these gas composition can be varied. Even sulfur can be there in the gas status in some planets because the temperature is very, very high. Even lead and iron can be there. In so some, right, that can be this. These materials can be there in gaseous status, right? So these are the things that you need to know about. Okay, then actually to check, so different features. There are a set of experiments, right? The lustre can be tested. So by like stretching or by cleaning using a sandpaper, or you can use, you can use, what do you call like that, to make it shine. The sandpaper is one option. Not only the sandpaper, there is more So in the vehicle industry, this uses B cut. Have you heard about this B cut? B cut. B cut is like, it's like a powder, right? It's like a B cut. Don't know, right? B cut is like a powder. This it's like a polish. So this is powder. It can be there as a liquid also. To here you can see when it is rubbed again, a surface of metal, or maybe especially in the vehicles, this is used, right? So this is used in cut and polish. So it makes the surface shiny. It makes this surface shiny. Brasho, I think you heard about brasho. Brasho අර ගාලා බැජ් වල එහෙම ඔයගොල්ලෝ කරනවා. අපි නම් චූටි කාලේ කරා. ස්කූල් බැජ් එකේ එහෙම පරණ වුණාම brasho ටිකක් ගාලා එහෙම කරලා තියෙනවද? නැද්ද?
No.
right brasho කියන එකත් ඒකත් polish කරන්න පුළුවන් අර ස්කූල් බැජ් මේ brasho කියලා තියෙන කඩේ ගන්න තියෙනවා මේක. මේ ඒකෙනත් පුළුවන් අර පරණ දැන් coin එකක් එහෙම අරගෙන coin එකක් එහෙම අරගෙන යා try කරලා බලන්න. This is interesting, right? අන්න පහේ කාසියක් එහෙම අරගෙන මේ බලන්න ඒක මේ වගේ පරණ එකක් අරගත්තම ඔයාලට පුළුවන් ඒක මේ වගේ polish කරලා ගන්න. You can polish like this. Just give a try. Just using brasho, right? Brasho is the, that is the chemical. මේවා brasho ගන්න තියෙනවා පුතේ සාමාන්‍ය කඩවල තියෙනවා. ඔයාලට අරගෙන මේක නිකන් මේ පුළුන් කෑල්ලකින් ගන්න තියෙනවා. It will actually clean the surface. It is like sandpaper. So it acts like sandpaper and clean the surface. That is the lustrousness of the material. Sorry. Then sonority. So that can be tested, but at least you have to take the thickness of 1 millimeter or more, right? Otherwise, this cannot be tested because if it is too thin, so you cannot hear this property. You cannot actually feel that very well. Therefore, you have to take a thick sheet. If you are taking thick sheet or thick wire, whatever. So thickness need to be tested. And when you take a thick one, you can just use a metal rod or you can drop it into the cement or floor and then you can listen. Right? රැව් දෙන හඬ කියන එක දැන් ඒක එනවා සාමාන්‍යයෙන් ඔය මොකද්ද coin එකක් වතුර බින්දුවක් වැටෙනකොට උනත් එනවා මේ නිකන් you can see when it fall down into the surface like a tank, metal tank, so that can be not just using that. So if you like ඒකට වැඩිය හොඳයි you can use a metal rod එකකින් තට්ටුවක් දාලා බලන්න ටංග ගන්න, right? ඒ වගේ so then you can test this property, right? Thermal conductivity here you can see these are like different materials, and then the candle wax is spotted or candle wax is put in different places. දැන් අපි ගත්තොත් තඹ කම්බියක්, යකඩ කම්බියක්, aluminium කම්බියක්. So let's take like that: aluminium, copper, and iron. Then you can take similar length, එකම දිග ගන්න, similar length and similar thickness. Then put some candle wax. ඉටි බිඳුව ගානේ දාන්න ඕන හැම එකටම. එකම දුරේ. Here also candle wax, same distance. Then you can use the Bunsen burner or gas, whatever, if available, or candlelight, anything, and you can start providing the temperature. You can increase the temperature. Then monitor which conducts faster, which conduct more faster. So mostly the thermal conductivity is there in most of the iron materials, right? If you take a stick, it won't conduct the thermal conductivity of stick. Maybe wooden stick is not really good. But if you take iron stick, so it will really conduct faster. So these are, and this is another thing, electrical conductivity, you need to be safe when you are doing this practical. Use small battery, don't use this like power available in your general power source, 230 voltage, that is dangerous, so dangerous. You can use small voltage, like maybe maximum up to 12 volt, or maybe like 5 volt battery, or 3 volt battery with LED. So that will be good. 3 volt battery with LED. Then actually you have to break the circuit somewhere. Don't complete the circuit. You have to break the circuit and keep it like this. Maybe you can use crocodile clips. Crocodile clips දැකලා තියෙනවනේ. The crocodile clips කොහොම නිකන් කිඹුල්ලු මතක් වෙන්න පුළුවන් වාට. මේ වගේ තියෙන්නේ අර මේ wire සම්බන්ධ කරන්න තියෙන්නේ. crocodile clips කියලා කියන්නේ ඒවට wire සම්බන්ධ කරන්න තියෙන මෙන්න මේ වගේ දැකලා තියෙනවා. Battery වලට. So these are the crocodile clips, right? Okay, you can use these crocodile clips for connecting. So what you have to do is you have to use the crocodile clips and connect different substances and check their electrical conductivity. You can even use water. You can use lime water. You can use copper wire, iron, aluminium, different materials, soil, sponge, a wet sponge, paper, a wet paper. Likewise, you can change the materials into different materials and check whether it conducts electricity. Other than carbon, most of the non-metal materials are not conductive, not electrical conductive. But carbon is electrical conductive. Carbon can transport, but most of the other non-metal materials cannot conduct electricity. Okay, since we have discussed a lot of points, I think we can discuss this part next day. So it's actually a very small part. To finish this lesson, we have to discuss about the metals and non-metals. I just indicated some, but we will be discussing this in the next class, right? Okay, then good night. See you next week. And we have to start after finishing this. I'll be doing the questions next day, right? Then I'll be starting the new lesson, sound that is interesting. I'll be starting this one. Then good night.
Okay, sir. Good night, sir. Thank you, sir.
Bye.